Greetings everybody. Today we are going to continue our unit on probability by specifically talking about mutually exclusive and overlapping events. You have been exposed to this a little bit in our discussions about set theory. You guys created Venn diagrams. You did so in such a way where sets A and B had overlap, which you put in the middle of a Venn diagram. Those situations are called overlapping events. And today we're going to talk about mutually exclusive events in addition to that. So mutually exclusive here, as you can see in the top of the notes definition, events that cannot occur at the same time. So they have no overlap. They're independent from one another. Okay. Before I go any further, I just want to point out that these notes are available in Schoology on the Google Agenda. You can pull them up. There's a key also available on the agenda. You can check along with that as we go or look at it later if you would like. Let's look at some examples together today. So here in example 1 we have two sets. We have a dodecahedron die, so that's 12-sided, and it says what is the probability that you roll the cube and the result is an even number or a 7. That word or is a key word here. Or means either even or a 7. So those two probabilities will be combined. Letter A says, let A be the event that you roll an even number and B be the event that you roll a 7. So let's start making our Venn diagram here. I'm going to zoom in. And let's start with the easier one, which is set B. Set B, there's only one element in there, and it's a 7. Okay? Now, I'm putting 7 distinctly in the B portion. So I'm distinctly putting it in this portion of the Venn diagram because it is not an even number. So it's not going to go in the overlap. So in set A, I'm going to put all the even numbers between 1 and 12. So that's going to be 2, 4, 6, 8, 10, 12. And again, all the numbers I put there are distinctly in set A because none of them are 7, so they're not going to go in the overlap section. We do have some numbers that were not included here. What about all the odd numbers? Outside of 7, all the odd numbers were not a part of our Venn diagram yet, so we still have to include them in our sample space. So there's all the odd numbers outside of 7. We still have to put them in our sample space. Let's look at some of these probabilities here using our Venn diagram. It says calculate the probability of A. Well, how many elements are in A? I see 1, 2, 3, 4, 5, 6 elements in A out of a total of 12 elements. So I would say 6 over 12, which is equal to 1/2. What about letter C? Calculate the probability of B. Well, there's simply one element in B, so it would be 1 out of 12. What about letter D? Calculate the probability of A union B. That's what that U sign means. U stands for union. That's another way of saying what's the probability of A or B. Okay, well you have 6 elements out of 12 in A, and you have 1 out of 12 in B. So altogether, the probability of either of them occurring is 7 out of 12. So you add them together. Well, interestingly enough, in letter E, you're really asked the same question in a different way. When the events are mutually exclusive, like A and B are, the probability of A union B is simply the combination of the probability of A and the probability of B. So you would have the same exact work here for letter E. Now, you may be wondering, are these answers always going to be the same? In other words, is this probability always going to be the same as this probability? The answer is no. But in this case, when they are mutually exclusive, they will be the same. Let's take a look at another example. This one is going to be slightly different than the first example. We still have our 12-sided die here, but our events A and B are a little bit different. It says let A be the event that you roll an even number and B be the event that you roll a number greater than 7. Okay, so I'm going to underline that, even number and a number greater than 7. So clearly there's going to be some overlap between these two events. There are even numbers that are greater than 7. So what I like to do is When I know there's going to be overlap, I like to start by considering that overlap and putting those elements in the middle. So, even numbers greater than 7. What numbers fall into that category? Well, you got 8, 10, and 12, right? Okay, now let's look at set A and B separately and figure out what would go in just those portions of the Venn diagram. So for set A, I want even numbers, and I've already included 8, 10, and 12 in the overlap, but what other even numbers are there between 0 and 12? Well, I have 2 and 4 and 6. And what about set B? That's the event that you roll a number greater than 7. So I already have 8, 10, and 12 in the overlap here, but there are some other numbers that are greater than 7 that have not been stated yet. So those would be 9 and 11. Are there any numbers that we haven't written in our Venn diagram yet? Well, there's 12 numbers altogether in the set, and we do not have that many numbers in our Venn diagram. The numbers that we have not written yet are some of the odd numbers here that are less than 7. 1, 3, and 5. They are all in the sample space, but they are not in the Venn diagram. They are in neither A nor B. Let's take a look at some questions here with this Venn diagram in mind. Letter B says, calculate the probability of A. Well, how many elements are in A? 1, 2, 3, 4, 5, 6. There's still 6 elements in A. They're not all exclusively in A, but they're all still a part of A. So 6 out of 12, which is 1/2. So far, it looks pretty familiar to the first question. Let's keep going. Calculate the probability of B. Well, how many elements are in B? 1, 2, 3, 4, 5. So that is 5 out of 12, which can't be reduced, so we just leave it 5/12. What about the probability of A intersection B? The upside down U is the intersection. Last time it was nothing, but here in example 2, we have 1, 2, 3 elements in the overlap. So we have 3 out of 12, which is 1/4. 1 out of 4 is the probability of an element ending up in the intersection. It says use the Venn diagram for the probability of A union B. Okay, well, how many elements are in either one? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 elements altogether there. That reduces to 2/3. All right, so now let's get into something important here in this example. It says key concept, the addition rule. If A and B are overlapping events, then the A union B, the probability of that is probability of A plus probability of B. But wait, what's this? Minus the probability of the intersection? Why would we have to do that? Why would we need to consider, why would we need to subtract out the intersection? Well, think about it. If I take the probability of A, which is all of this stuff, and then I take the probability of B, which is this and this again, oh my, I just counted the middle twice, didn't I? I just counted the middle twice. So that means when I'm calculating the probability of A union B and there's overlap, I have to subtract out that intersection portion once, or else I will double count it. Okay? So what does that look like here in this situation? Okay? Well, if we use the addition rule to verify this, it says use the addition rule to calculate the probability of A union B, verify the result in part E. Okay, well, let's take a look. Let's verify this. The probability of A union B, we already found that to be 8/12. I'm going to leave everything in terms of 12ths here. And that equals the probability of A, which is 6/12, plus the probability of B, which is 5/12, minus the intersection, which is 3/12. Altogether, that's 6 plus 5 minus 3, that's 8/12. This is a true statement. This verifies that these events are indeed overlapping, which we knew from the Venn diagram, but it just goes to show and to prove that to calculate the probability of A union B in an overlapping situation, we have to add together the probabilities of A and B and then subtract out that intersection once to get the probability of A union B. Let's look at one final example here. This is example 3, and it has a two-way table. You may have seen some two-way tables in Algebra 1 and maybe in 8th grade math. They're back here in geometry, believe it or not. So here we go. It says, use the given two-way table to determine the probability of senior or girl, senior union girl. First question, are the two events mutually exclusive or overlapping? Well, the question you have to consider is are there girls who are seniors? For sure. So they're going to be overlapping events. There's going to be some overlap between seniors and girls. Next question, which method will you use to calculate the probability of senior union girl? Mutually exclusive or the addition rule? Well, the addition rule is what we're going to have to use. That's the one we learned in the last example, where we have to subtract out the overlap to find the probability of the union. Next question says, to determine the probability of senior union girl, first calculate the probability of senior, then the probability of girl, and then the intersection of the two. All right, well, let's go through one by one. The probability of a senior, I'll just abbreviate here, the probability of senior is going to be, how many seniors are there? There's 202 out of a total of 808. And so the probability of a senior is 202 over 808. And that does reduce to 1/4. What about the probability of a girl? The probability of a girl would be 412 girls out of 808. So 412 out of 808. That reduces to 103 over 202 if you reduce that in your calculator. And what about the probability of the intersection? I'm running out of space. I'm going to say probability of senior, S, intersection G. What's the probability of a senior girl? All right, so let's find the intersection between those. Seniors, there's the column for seniors. Here's the girl row. Senior girl would be 108 out of 808. And that reduces to 27 over 202. All right, so to calculate the probability of senior union girl, we have to use the addition rule. So we have to add together this plus this minus this, right? And so you don't have to do it by hand. Put it in your calculator, for goodness sakes. Use parentheses. Say parenthesis 1 over 4 plus parenthesis 103 over 102, parenthesis plus parenthesis 27 over 202, parenthesis, and convert it to a fraction in your calculator. When you do that, so when you add together the two that are highlighted in green and subtract out the one highlighted in red, you will get 506 over 808, which reduces to 253 over 404. So that would be your final answer for the probability of senior union girl. So here again, because these events are overlapping, we have to use the addition rule and make sure to subtract out that intersection once. When you're reading a two-way table, make sure you're very careful with the wording and such. For example, if you're looking for just the probability of girls, that's a marginal probability, 412, and then you have joint probabilities here in the middle of this table. These are called the joint probabilities. These are called the marginal probabilities here in the margins. So just be aware of the wording of what you're being asked and make sure you get the correct probability, and then just throw it into the calculation. You'll get your answers that way. Hopefully this was helpful. Complete the rest of the items on Schoology there that I've assigned. And please, please, please make sure you sign up for a conference. If you have any questions, do so on Schoology. All right, thank you.